In order to use the F distribution for ANOVA, we need to make sure certain conditions are satisfied. One of these is a normality condition, which refers to the shapes of the individual samples. Ideally, it refers to the shapes of the individual populations, but we often don't know that, so we settle for the shapes of the samples. And this is a very similar condition to what we are familiar with for t-distributions. If each sample has at least 30, we usually assume that it's okay to use the F distribution. Unless we see an extreme outlier, then we might have to look a little bit closer. But if n is less than 30, we definitely want to watch out for signs of clear skewness or outliers. In this case here, n is equal to 20 for each of these. So we do care a little bit what the shape is, but they all look pretty reasonable. They're never going to look like perfect bell curves, especially with n equals 20, but we don't see heavy skewness or extreme outliers at all. So this one looks good. Normality condition. Is okay. The other condition is equal variance. This says that the standard deviations of the three populations, or however many we may be comparing, can't be too far apart from each other. And the way we check this is by looking at the standard deviations of the samples, the individual samples, and we check that the largest is no more than twice as large as the smallest. So in order to check this, we have to go back to our summary statistics. The three standard deviations that we're interested in are those for good, bad, and none. We don't want to look at this overall standard deviation. That's for the whole data set pooled together. It's okay if that's really big. So the largest here is 2.4. The smallest is 2.0. And we can see that the largest is clearly less than twice the smallest, so our equal variance condition here is met also. Since our largest is not more than twice the smallest, we'd say equal variance condition okay. If either of these conditions is not met, it might still be possible to do an ANOVA using a randomization distribution, but we would not want to use the F distribution, the theoretical distribution, which requires these two conditions to be met.